Hi, welcome to the Calculus 2 lecture series. And we are in the unit number 2. We talk about the different techniques for the integration. So this is our lecture number 8. So in this lecture, we're going to talk about how to do the trigonometry substitution. And from the lecture number 7, if you still remember, we had 4 videos talk about the lecture number 7. In the lecture number 7, we talk about how to do the trigonometry integrals. So we find the different techniques for all the tricks combination like sine, cosine, tangent, secant type of the combination. How do we do the integration? And so now this is the one, instead of the integrands have the trig functions. It's the typical algebraic function. And then what we try to do is how can we use trig substitution to simplify our integration? And then we'll be able to apply the techniques we learned in the lecture number 7 and try to help us to do it. All right. Okay, so now let's go to our lecture notes and let's see what is this trigonometry substitutions here. All right, let's go to our techniques, the lecture notes here. Okay, so the key concept for the trig substitution. Okay, so I think at the very, very beginning, like when we learn the integration, we talk about the U sub, right? So I think everybody is very kind of familiar with the U sub. So what do we do? The U sub is like if you have, for examples here, okay? So if you try to integrate like e to the x squared, x dx, right? So now when we talk about the U sub, so that means we use the U to substitute one of, the functions here. So the U sub will say U is equal to the x squared. And then you do a du, and then this will be the 2x dx. Then because here you only have x dx, you adjust the constants. So this is du over 2, and this is x dx, right? This is what we talk about is the U subs here, okay? And now in here, so now what is, this is what we call is the, the trig substitution. Okay, so it's not you substitute a u is equal to a function of x here. So basically, for the trig substitution, basically we try to, so when you try to evaluate the integration, the f of x dx here, right? So now you will replace your variable x, okay, by a function. Okay. So since we call this the trig substitution, so this function typical is a trig function. Okay, then the purpose here is you try to change this one to be a, so after you replace by a trig function, then basically you change this one, you switch this integration to what? To the trigonometry, the trig integrals. Right, then we'll be able to use the technique we talked about in our previous lecture. How do we do the trig integrations, right? Okay, so to see the differences, right? So the U sub, you use a single, like a variable U, then you substitute the function of x. And then now for the trig substitution, you replace the x by a function. So because we call it a trig substitution, so you replace it by a trig function. So your goal is here to switch this integration into a trig integral. Just like in the U sub, you try to switch this integration to a function of the U, then you can take the integrations here. Okay, so in here, this is a very kind of important table. So I'm going to give you, so what the trig function you can, what is the trig substitution you can, used. So the first one's here. I want to put here, this is the integrand. Okay, then here, this is the substitution we use. And so this is kind of the triangle going to help us. Okay, so what's that mean? So let's take a look. All right, so the first one's here is if your integrations have the, okay, so if your integrand have the form like this, square roots of the a square minus x square. Okay, so if you have the a square minus x square, then what type of the trig substitution you can use here? So because this is a square, right? So we said the trig substituting, you assign the the variable x to a function. So in here, you assign that the substitution will be what? Will be a sine theta. Okay, so you switch that to a trig function. So basically what you will have here, you will have x, right? So x equal to the a sine theta, or you can say x over a is equal to the sine theta here. Then in here, you can do the dx here, right? So the dx will be what? A will be what? Cosine theta, d theta here. All right. And then, what is this a square minus x squares will be, right? So now this is where this triangle going to help you see here. So let's see here. So when you do the problem, you always, when we try to do the practice, you will find the problem here. So you will use the triangle to help you. This is my thetas, right? So the sine thetas here is x over a, right? So the sine we know is what? Sine is opposite over what? Over hypotenuse, right? So it's x over a. So this is the x and this is the a. Am I right? All right. So now, because now I can use the Pythagorean series here. So the Pythagorean series, so this is x, this is a. What is the Pythagorean series here? So this side will give you what? A square minus what? X square. Arbitrary, right? So that's what this is the, we have here. Right, so this will be the a square minus x square. It will be what? It will be the cosine theta here, right? So that is pretty cool, right? So that's what you do so that's why you will say, okay, this is what we're going to have. This is a square minus x square. That this one is equal to what? This is the cosine theta, right? Okay, so now your whole integration can be changed to a trig function, the sine, cosine, secant, the secant or tangents. Okay, let's take a look at the next ones here, right? So if I have this one's here, if I have a square plus x square, then what is my substitutions here? So in here, let me color code that. So in here we can say x is equal to what? X equal to a tangent theta. Okay, if x equal to the a tangent theta, so I know that x over a is equal to what? Tangent theta, right? And now let's take a look what is the dx here. Dx is be equal to the a. What is the tangent theta? The derivative is the secant square theta, d theta. All right, so now let's take a look what is this one going to end up to be, right? So tangent is equal to what? Tangent is equal to the opposite over adjacent, right? Okay, so now let's take a look at the triangles here. All right, so here, this is my triangle and this is the theta. So tangent is opposite over adjacent. So what is here? this is the, let me use the color coding, so that would be good. So this is x over what? This is x over a. And then by Pythagorean series, what is the hypotenuse? Hypotenuse will be a squared plus what? X squared, right? Well, R is equal to here, right? So a squared equal to the x squared here, right? So now, if so, what is this one going to be? We know the tangent secant, right? They always have a relay. So this one here is what? So this one, if you say is the secant theta, secant is what? Secant theta will be a over a squared plus x squared. This will be equal to the secant theta, correct? All right, so is the, oh, no, okay, so the secant is, secant here is hypotenuse. So it's a squared plus x squared, hypotenuse over adjacent here, right? So that will be the secant theta here. So this one's here, right? So this one you can rewrite as the, the a squared plus x squared will be a times what? A times secant theta here. All right, and this one's here, I need to be careful. I'm not a cosine theta here. I need to be careful here. Okay, so here, the first one, the a squared minus x squared. So in here, I should, okay, so we should say the cosine theta is equal to the a squared minus x squared over a, right? So I need to be very careful about my writing. So then you can say this one be equal to the cosine theta, and this one is equal to the secant theta here. Okay, so now the next one's here. Okay, so the next one's here is will be, how about I have x squared minus a squared, right? Okay, so for the x squared minus a squared, what type of the substitution I need to use? So I will say x is equal to what? X is equal to the a to the secant theta. Okay, and now let's do the same thing. So the x over a is equal to what? The secant theta, right? And the secant theta is what? Is the hypotenuse over adjacent, right? Okay, now let's take a look the derivative. So I know that dx is equal to a. Secant theta, the derivative will be secant theta tangent theta d theta, right? Okay, so now let's take a look at this triangle again. So this is a very helpful triangles, right? So here, so this is the theta. All right, so let's color code that. Okay, so x secant theta is equal to the hypotenuse over adjacent. So it's x over what? X over a. Right? And now by the Pythagorean series, if this is a hypotenuse is x adjacent, say what is this side? This side will be what? X squared minus a squared, right? So it will be like this, right? So it's so this side will be x squared minus a squared. Okay, so now I can rewrite this. I will set okay, so like in here, this is x squared minus a squared, right? Okay, so I can say this one's here will give you, so if the sine theta will be equal to okay, so sine theta will be equal to the x squared minus a squared and over x here. Okay, so here, and be careful because I have the secant. Secant has to be in the partner with the tangent here. So this is x over. So I can say the tangent theta is equal to what? The tangent is opposite over adjacent. So this is x squared minus a squared over a, right? So now the x squared minus a squared. So what is here? That will be a tangent theta is equal to the x squared minus a squared. So this is x squared minus a squared. So this is what? This is a tangent theta here. All right, so be very careful. This set of the formula is very specific, right? So like if you have x minus a, what do you need to do the substitution? If you have x plus a, what do you need to do the substitution? What happens if you have a squared minus x? What type of substitution you need to do here? All right. Okay, so now let's take a look here. Let's take a look at our problem. The first problem is here. They said, hey, you know, like when you do this type of integration without the trig substitution, probably will be very difficult to do. So that's why I said, okay, try to rewrite, use a trig substitution. They just want us to rewrite it, and then no need to carry out. We're going to do some other problem we'll be able to carry out. Okay, so for here, let's take a look here. This is 4 minus a squared. So this is what? This is my a squared, right? So this is a squared minus x squared. So here is the first one. So what is my substitution will be? X equal to the a sine theta. Correct? So that's what I need to do. The x equal to the a sine theta here. So I will say x equal to the a. So this is a squared. So it's 2 sine theta d theta. The 2 sine thetas, right? Okay, now we know so just like we did a while ago, so the dx is equal to the 2 cosine theta d theta, right? And also then we know from here, the a squared minus x squared, what is this one will be? This one will be a cosine theta, right? So I know this one's here, so that means I should use the color coding, so match what we did before. Formula. So also we know from the previous triangle, so I know 4 minus x squared is equal to the 2 what cosine theta, right? Okay, so now everything in here I can substitute. Okay, so let's take a look here, right? So now I'm integrating here. Okay, so now I'm integrating. So what is the x squared? Okay, so x squared, so this term is x squared. X is 2 sine theta, right? So x squared will be 2 sine theta, the whole thing squared. Okay, then we just did this square root of 4 minus x. So this part, right? So this part, what is that will be? That will be the 2 cosine theta. Okay, so the last part is the dx part, right? So this is the dx part. So what is the dx part will be? Will be the 2 cosine theta d theta, right? So let me color coding that so you know which one I replace. This is the 2 cosine theta. This is the 2 cos, then the corresponding, right? So you see the color code. Now you see I changed everything, become a function of x. I change it to a trig integrations, right? Now we'll be able to use the technique we learned previously. So let's take a look. It's 2 to the square is 4. 4 times 4 is 16. So it's 16 sine square theta cosine square theta d theta. So now you know how to carry out this integration, right, from the previous lecture. So this is sine, cosine, both are the even numbers. So I need to probably use a half angle formula to solve it. All right, so now let's take a look at the next ones here. This is x squared minus 9 here. So let's see here. Okay, so x squared minus 9. X squared minus 9. So it's this formula I'm going to use, right? So x equal to the a secant theta. Okay, so for this problems here, because this is x squared minus 9, so what is 9 here? 9 is my a squares, right? So that's why the a is equal to what? Equal to 3, right? So now, based on my formula, we just in this table, x equal to the a secant. So now let's try to do that. So we will say x equal to a is 3, so it's 3 secant theta. All right, 3 secant theta. And now I need to have a dx. So dx is the 3 secant theta tangent theta d theta, right? Okay, so now because from the previous we know this number here x squared minus 9 from the triangle. Okay, from the triangle, x squared minus 9 is equal to what? Is equal to the a tangent theta. So a is a 3, so this is a 3 tangent theta, right? So by the triangles, right? So now I have everything I have here. So the same way is here. The first, the x squared. So first the x squared term. So what is the x squared? Is 3 secant theta to the what? It's squares, right? So here color code so you know which one I replaced. And then the x squared minus 9 is here. So this is the 3 tangent theta, right? So the 3 tangent theta, so it's in here. Let's replace with here. Then the last one is here. I still have dx. So dx, this is 3 secant theta tangent theta d theta, right? So this is the last term I need to replace, and I replace in here. So that is really beautiful, right? So I replace everything into a trig function, the tangent and the secant. So let's see here. So it's 9 to 9, 3 to 3, the square is 9. 9 times 9 is 81, right? So I have this is 81. Then this is a secant square secant. So it's a second. So it's a secant square. So secant to the what? Cube theta, right? Then I have a tangent. So I have a tangent square theta, right? So now, just like the first one, I change this into a trig, the trig integration. Now, because the second is the odd number, maybe we can take 1 secant tangent out, just like learn the technique we did from the how to do the trig integration. Okay, so now the last one is here. Okay, so this is x plus 1, the square root of 4 plus x. Even the 4 plus x is on the, okay, so it's on the denominator, right? So let's take a look at a plus x squared. A plus x squared will be what? A plus x squared. Oh, I can use the tangents, right? So a plus x squared. Okay, so let's see here. A plus x squared. So I know what is here. This is my what? This is my a squared. Correct? Okay, so this is my a squared. So what is my a? A is 2. So a squared plus x squared. So it's here. So I want to use the transformation x equal to a tangent theta. Okay, so let's see here. So I will say x equal to the a. So it's 2 tangent theta, right? So x is equal to the 2 tangent theta here. So as always, take the derivative. So dx is equal to the 2 secant square theta d theta. right? And also from the formula, we know if I said this is a tangent theta, so what is this one is a secant theta, right? Okay, so a secant theta. All right, so let me do the color code so I know from the previous. So the 4 plus x squared is equal to a to the secant theta. So it's 2 to the secant theta. Correct? Okay, now let's see here. Now we will be able to do the substitutions here, right? Okay, so everything need to be replaced. X plus 1. All right, so the x plus 1, so what the color we used here? Oh, we use the yellow. Okay, so x plus 1, so we will have these terms, right? So x plus 1. Okay, so x plus 1, it will be what? It will be 2 tangent theta plus 1. All right, then in here dx, the dx is times 2 secant square theta d theta. Then the bottoms here, this is 4 plus x squared, right? So will be the 2 secant theta. So let's see we got everything covered or not. So this one's here, right? So this one is 2 secant theta, and this one, all right, so the dx is here, dx is this one is 2 secant square theta. All right, so now I can simplify a little better. So this one's here, the 2 and the 2 I can cancel. So you already have the 2 tangent theta plus 1, and oh, it's a cancel out. So here basically I can this 2 and the 2 cancel. I can cancel out the 1 secant. So this will be 2 tangent theta plus 1. All right, 2 tangent theta plus 1. And now this is the secant theta, d theta. So if you want, then you can, FOIL that. So this is a tangent theta, secant theta, d theta, then plus the secant theta, d theta here, right? And then we can just, use the method we learned from the from the previous lecture to carry out the integration. All right, so I would like to stop in here, and then for the next video we're going to physically carry out those integration to see we still remember how to combine this technique. We did a trig substitution first, then we use the trig integration. All right, so this will be a first video, and I'm going to stop here, and we're going to come back here to do some problems here. All right, okay, talk to you later. Okay, bye.